What's up? I'm Vin, and today I want to go through the January 2024 Algebra 2 Regents, and I'm going to go through the multiple choice questions, and I'll leave a link to a copy of this test in the description below. Now let's get started. Question 1, a cafeteria food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch in the cafeteria, brought their lunch from home, or purchased lunch from an outside vendor. This collection of data would be best classified as. Okay, this cafeteria food manager is just observing here, okay? They studied the lunchtime eating habits of a group of employees. So they're just watching, okay? They're just watching if people are either purchasing lunch, bringing their lunch from home, or purchasing from an outside vendor. So this is just an observational study. It is not a census because they're not going around, questioning people or anything like that. So one is out. It's not an experiment because they're not rigging the cafeteria and trying to see what happens if one group is doing one thing or one group is doing another. They're not trying to see how they react to a certain situation. They're just observing, okay? They're not interacting with the environment at all. And it's not a simulation because this is actually happening here. Okay, so a simulation is out. They're not running a computer program to see what happens over 500, events. Like if they run it 500 times, and there's a lot of cases here, then you'd be talking about a simulation. But here they're just studying, just watching. So choice 3 is our answer. Question 2, which graph has imaginary roots? And all of these graphs are graphs of quadratic functions. So when you're looking for the one that has imaginary roots, you want the one that does not intersect the x-axis. So just looking through the answer choices, choice 1 is out because it has 2 real roots. It crosses the x-axis twice. Choice 2 is our answer because this quadratic misses the x-axis completely. It has a maximum point here that is clearly under the x-axis, so this parabola is never going to hit the x-axis. The problem with choice 3 is that it has 1 real root. The parabola is tangent to the x-axis. It just touches at one place. And then choice 4 is no good. This quadratic would have 2 real roots. So choice 2 is our answer. Now, something that resembles a graph like this, another one that misses the x-axis completely. I think of one like, let's say this were at y equals 1. I could have something like x squared plus 1. Okay, so this could be a graph of, let's say, y equals x squared plus 1 above. And if I set this equal to 0, so x squared plus 1 equals 0, I can subtract 1 on both sides. So we'll just make this a little bit neater. So we're going to do minus 1 on both sides. And we have x squared equals negative 1. So when I take the square root of both sides, I'm going to have x equals, I get plus or minus, and the square root of negative 1 is I. Okay, so there are the 2 imaginary roots, and notice this is a quadratic that the parabola misses the x-axis completely. Okay, so that's what I automatically look for. And if you know what to look for these questions, you could answer very, very quickly and eliminate all the other answer choices. So 2 is definitely our answer. Question 3, given 3 is a root of f of x, what are the other unique roots of f of x? For the Algebra 2 Regents, we're allowed to use a calculator the whole time. So we could just type the function f of x right into the y equals spot. We could press x to the power 4, and we hit the right arrow to get out of the exponent spot. And then we have minus x to the power 3. And then next we have minus 21x squared. And after this, we have plus 45x. Okay, so here is the function f of x. And now when we press graph, we'll have all the information we need here to answer the question. So to find all of the unique roots of f of x, we could just look at where this graph crosses the x-axis. And this happens in 3 places here. We have a root at x equals negative 5. We have a root at x equals 0. And if we count out, we have a root at x equals 3. They told us that 3 is a root of f of x. So the other unique roots of f of x are going to be negative 5 and 0. And this is going to match up with choice 2. Now, for something like this, if you want to do this question algebraically, we could use the fact that 3 is a root of f of x, and that'll help us find the other roots of f of x. So something like this, f of x, first we could factor out an x. So here, if I take out an x and I divide each term by x, I'm going to have x to the third, I'm going to have minus x squared, I'm going to have minus 21x, and I'm going to have plus 45. So from here, what we could do is we can make use of the fact that x equals 3 is a root. And we could use polynomial or synthetic division to find how to break this down even more. But let's use synthetic division to break this down. I'll show how to use polynomial division later on in the video. So I want to divide this polynomial by x minus 3, because if x equals 3 is a root, that means that x minus 3 is a factor of this polynomial here. So I'm going to write the coefficients of this polynomial on the inside. We have 1x to the third, we have minus 1x squared, we have minus 21x, and then we have plus 45 at the end. And then the root x equals 3 we're going to write in front, and we could begin the process. So we're going to bring down the first value here, 1, and we do 3 times 1 is 3, and then negative 1 plus 3 is 2. Then we do 3 times 2 is 6, negative 21 plus 6 is negative 15, and then we do 3 times negative 15 is negative 45, and we have no remainder here. And what this means is that if we divide this polynomial here by x minus 3, the leftovers are going to be given by what we have here. So we have 1x squared, we have plus 2x, and then we have minus 15. So that tells us that we could break down this polynomial here as x minus 3 times x squared plus 2x, and then minus 15. And now what we could do is we could factor, we'll just make this a little bit neater. So we have x squared plus 2x minus 15. We're going to break this quadratic down. So now I'm going to say that f of x in factored form is x times x minus 3. And then we look for two numbers that have a sum of 2. And we want the two numbers to also have a product of negative 15. So we're just factoring this quadratic part. And the factors would be, we would have x, and we're going to have plus 5 times x minus 3. And notice here that we have matching factors. We have x minus 3 times x minus 3. So what that tells us when we find the roots, that this factor is going to give us a root of x equals 0. This factor is going to give us a root of x equals 3, which was the one they told us in the beginning. And then the x plus 5 is going to give us a factor of x equals negative 5. So you could see that the two new unique roots are negative 5 and 0. I wouldn't write x equals 3 a second time. So when you have repeating factors, you just write the root once. But you could see here, if we do this question algebraically, we're going to get choice 2. Question 4, given p is not equal to q, p equals 1/2 to the q power, expressed in logarithmic form is equivalent to, and we have these 4 options here. So for this question, if you know how to go from exponent to log form, this question could be done very, very quickly. So we look at the base of our exponent is 1/2. So that tells us that the base of our log is going to be 1/2. So we write the base over here in this little spot. So I could see right away that our answer choices are narrowed down to choices 3 and 4. So 1 and 2 are out. And then what we have next is that our exponent is going to go after the equal sign. Okay, so the exponent here, the q, is going to go after our equal sign. So we have q going over here, and the result goes inside the log. Okay, so the result goes inside the log. So I have log base 1/2 of p is equal to q. And if I want to go from log form back to exponent form, I like to make this circular motion here. I have my base is 1/2 to the q power is equal to p. But if you just want to use the calculator in a clever way to just run through all of the answer choices, what you could do is just pick out values here. So let's say I picked out something like q is equal to 3. If I plug in here 1/2 to the third power, 1/2 to the third power, that's 1/2 times 1/2 times 1/2 is equal to 1/8. So that would tell us then if 1/2 to the third is equal to 1/8, that would give us p is equal to 1/8. And then what I could do is I could just plug these values into the calculator and see if it matches up with our answer choice here. And let's just match this here. This is going to match up with choice 3. So we're going to plug our value of p into the log here and see if we get the value for q. So if I want to make log base 1/2, I press the math button and I go up, and you see log base is option A. So I just go up to log base, and my base is 1/2. So I'm going to write 1/2 here. And then inside the log, we're going to have p, which is equal to 1/8. And if we did this correctly here, we should get q, which is equal to 3. And it does, in fact, check out. Now, if I were to plug into, let's say, the other answer choices here, like let's say y is choice 1 no good. I press math, I go up to log base, and I replace the base here, p, with 1/8. And then inside the log, we have 1/2. And let's see what we get here. So we get 0.33333, which would tell us the value of q should be 1/3, but it's not. Q is equal to 3. So you could see that, once again, you could pick out a value for p to plug into, or you could pick out a value for q to plug into the original equation and see which value of p it gives you. and then just run through the answer choices and eliminate. But if you know how to go from exponent to log form and back, this question you could do very, very quickly. Question 5, which graph best represents the graph of f of x where a and b are positive real numbers? So for this question, there's a few ways that we could go through this, but one really fast way to get to the answer without the calculator is to just analyze the y-intercept of the 4 answer choices and the one that comes from the equation. So if I want to find my y-intercept from my equation, I plug in x equals 0. So if I plugged in x equals 0, I would have f of 0 equals, and then I have 0 plus a squared, and then I have 0 minus b. And from here, 0 plus a is equal to a, and a squared is a squared. And then 0 minus b is negative b. So what I'm doing here is I'm doing a squared times negative b. So that's our function value at 0. But they told us a and b are positive. So that tells me here that this term is going to be positive, but if I put a minus in front of my positive number, this one's going to be negative. So when I do a positive times a negative, our value for f of 0 is going to be less than 0. So what this tells me is that our y-intercept is under the x-axis. Okay, so the y-intercept is under the x-axis. And now we just look through the answer choices. So this is under the x-axis. And if you look, you could see for choice 1, the y-intercept is under the x-axis. So this is already looking good. Choice 3 is no good because the y-intercept is above the x-axis. And then choices 2 and 4 are out because it looks like when x equals 0, y is equal to 0. But here we have a and b are positive real numbers. So the y-intercept would have to work out to something negative. So just by plugging in 0, we could get this to choice 1. But once again, you do get to bring a calculator to the test. So I would do something like this to double check. So I have x plus, and let's say we let a equal 1 because a has to be positive real. So we'll choose a equals 1. And then I'm going to let b equal 2. So I have x minus, and then b we're going to say is equal to 2 because a and b are positive real numbers. So I'm going to let b equal positive 2. So I'm doing x minus positive 2 here. And now we press graph. And for this one, we just have to match it to the answer choices. And we could see the only one that resembles this is choice 1. The other answer choices here are no good. Like this one here, you could see that the y-intercept is positive. And even so, this one starts out looking like this. So it's like decreasing first, then increasing, and then decreasing. This one goes up, down, and up. Okay, so looking at the other answer choices, this one does go up, down, and up, but the y-intercept does not line up like this one should here. And another detail to point out here is that the x plus a factor is being squared. So what that tells us here, when we have x plus 1 squared, at x equals negative 1, notice that this root of our function, the curve is tangent to the x-axis. It doesn't go through the x-axis. It approaches the x-axis, it touches at negative 1, and then it drops back down. So that's another detail we could look at. We have an even multiplicity here that the root, the graph is going to be tangent to the x-axis at that location. But notice it's x minus b to the first power. So when we have the root at x equals 2, the graph goes through the x-axis like this. If I were to switch this to x minus 2 squared, then both of these would be tangent to the x-axis. Okay, at both roots, you see we would have 2 tangents to the x-axis at both roots. So if the power of your factors are even or odd with your x term on the inside, that's going to change the behavior of the graph in that neighborhood. Question 6, we have these two equations here, and they approximately model the growth of 2 separate populations where t is greater than 0. What is the best approximation of the time t at which the populations are the same? So for this question, I'm just going to graph both of these at the same time. So I'm going to have 3t plus 6, but we'll go ahead and use x. And then we have 1.82 in parentheses to the power t. So we have a linear and an exponential function here. So we press graph, and just looking at this right away, we could see that we have a point of intersection here. So if we press second trace 5, and we go up to this, and we press enter 3 times, this is going to tell us that one of our points of intersection happened to the nearest 10th. If we round to the nearest 10th, we have x equals negative 1.9. So choice 1 should be our answer. But no, choice 1 is a very dangerous bear trap. Notice they said where t is greater than 0. So these curves, or this curve and this line, will intersect one more time. if we were to look at the table here, second graph, you could see that the red is eventually going to surpass what we have here in blue. That represents the points on the line. So what I would do here is make the graph taller. Let's say I put the graph to go up to something like 200. If I go to the window and I go to the Y maximum and I switch it to 200, and then I press graph, notice here that I could see where the graphs intersect. Maybe I want to shrink this a little bit because this is a lot of excess here. I could just drop this down to something like 100. And since t has to be greater than 0, I could switch my x minimum to 0 so that I don't look at any negative x values. And you could see there's our true point of intersection that we want. So we do second trace 5, and we go right up to the point here. We scroll, we press enter 3 times, and our true point of intersection is going to be at 5.1. So our solution to question 6 is going to be choice 3. Question 7, we have these two equations here, and we're looking for the point of intersection that falls in quadrant 2. So right away, what I'm going to do is I'm going to cross off any point that is not in quadrant 2. So when I think about the xy axis, quadrant 2, any point that you find here, the x coordinate is going to be negative and the y coordinate is going to be positive because we have to go to the left of the origin and then up to get into quadrant 2. So looking through the answer choices, the only one that's not in quadrant 2 is choice 1. So we could eliminate this one right away. Now, the quickest way to get through this would be to just plug these points into both equations and see which one satisfies both equations. So let's say I plug in choice 2 into the first equation. If I do y equals negative 2 times x is negative 2, negative 2 times negative 2 is positive 4, but the y value is 1, not 4. So that's why this point is not going to be a point of intersection between both of these equations here, or the graphs of these equations. So moving on now to negative 1, 1. If I were to plug this into the first equation, I would have y equals, and I have negative 2 times x, and here my x is negative 1, so I do negative 2 times negative 1 is positive 2, and I can see right here that this also doesn't match. So narrowing this down right away to choice 4 tells us choice 4 is our answer. So process of elimination is a very effective way to get to the answer. But if I want to verify that this point does check out, I plug in, I have y equals negative 2 times negative 1 is positive 2. So this point checks out with the first equation. And if I plug it into the second equation, I have x is negative 1, and I'm squaring it, plus y is equal to 2, and I'm squaring this. And if I simplify, I get negative 1 times negative 1 is 1, 2 times 2 is 4, and 1 plus 4 is definitely equal to 5. So choice 4 is definitely our answer. Now, if you want to solve this question algebraically, what you could do is you could solve this system of equations by substitution. So we could plug in the equation y equals negative 2x into the second equation here. So I'm going to do x squared plus y squared. I'm going to leave y out, and y is equal to negative 2x. So I'm going to plug in negative 2x for y, and then this is all equal to 5. So now from here, x squared is just x squared. And then for this, anytime you want to do a product to a power, you could just raise each term to the power like this. Okay, so this is just a property of exponents that we could use here. So I do negative 2 to the second power, or negative 2 times negative 2 is 4. And then x to the second power would be x times x, which is x to the second power. And this equals 5. So now I combine like terms. I have 1x squared plus 4x squared is 5x squared, and 5x squared equals 5. I could divide both sides by 5, and that's going to give us x squared is equal to 1. Now for this part, we could just do the square root of both sides, but we have to be careful and make sure that we say x equals plus or minus 1. If you want to avoid this trouble, just know when you have x squared equals 1, you could also, so I'm going to say here, or we could do this. We could subtract 1 on both sides to get x squared minus 1 equals 0. And then we could use the difference of two squares factoring and factor this as x minus 1 times x plus 1. And we're going to get a root of x equals negative 1. And we're going to get a root of x equals positive 1 here. And remember, we have to select the point that's in quadrant 2. So I know my x has to be negative, so I would reject x equals positive 1. And then if we look, we have two answer choices where x equals negative 1. But if we plug x equals negative 1 into any of these equations, x equals negative 1 is going to give us y equals negative 2 times, and I'll just make this neater, so we have negative 2 times negative 1 is positive 2. And we could see that choice 4 is definitely our answer. Question 8, we have the rational expression here is equivalent to, and for this question, I'll show polynomial division. We could still use synthetic division here, but I'll just show both techniques just in case you prefer one over the other. So here we're dividing 2x to the fourth minus 5x squared. And notice there is no x to the third term on top. So I'm just going to put a plus 0x to the third. I like to show the placeholder method here because I find it helps students stay organized when they're going through this lengthy process. So next we have minus 5x squared. Then we have plus 3x and minus 2. And we are dividing by x minus 3. So the factor we divide by goes on the outside. And with this process, we just focus on the leading terms here. And this is very similar to elementary school math when you did something like 108 divided by 7. You said 7 goes into 10 once. 1 times 7 is 7, and we subtract. And then 10 minus 7 is 3. That's our remainder. And then we bring down the next term here. 7 goes into 38 5 times. 5 times 7 is 35, and we subtract. And then we have a remainder of 3. And that remainder 3 goes over the divisor here. Okay, so this was the elementary school way. We'll just make this a little bit neater. So we have 3/7 at the end. And the technique is still the same, but now there's just x's involved. So we're going to do 2x to the fourth divided by x is 2x to the third power. And we multiply 2x to the third times x is 2x to the fourth. And then we multiply 2x to the third by -3, and we get -6x to the third power. And now from this part, we're going to subtract. Now, the most common mistake is that people just subtract the first term and they don't change the sign of everything. You're technically subtracting this entire polynomial. So the minus would have to distribute through, and that would make a minus 2x to the fourth and a plus 6x to the third. So what I like to do for these questions is I just change the sign of everything and then I combine. So here, these terms are going to cancel. We're going to have 0 plus 6 is 6, so we have 6x to the third power. And now I bring down the next term, so we have minus 5x squared. And the process starts all over again, and it keeps going until we bring down the last term. So now we're dividing 6x to the third by x, and that's 6x to the second power. And now we distribute, we have 6x to the third, and then 6x squared times minus 3 is minus 18, and we have x to the second. And then same idea, we subtract, and that changes the sign of everything from where we're subtracting. And now these terms cancel. And then we have -5 plus 18 is 13. So we have 13x squared. And from here, we bring down the next term. So we have a plus 3x. And we divide our leading term here by the leading term of our divisor. So we have 13x squared over x is plus 13x. And now we distribute 13x times x is 13x squared. And then 13x times -3 is -39x. And then we subtract, so we just change the sign of everything. We have minus, and then this changes to plus. These terms cancel out, and we're going to have 0 plus 42x. And then finally, we bring down our last term. We do this process one more time, and we're doing 42x divided by x is 42. Okay, so we get here, and we distribute. We have 42 times x is 42x. 42 times -3 is going to give us -126. And we subtract, so we're going to change the sign of everything. And our remainder here, when we do -2 plus 126, is 124. So we write the remainder at the end, but we're dividing it by the original divisor is x minus 3. So now we just look through the answer choices here, and we're going to see this matches up with choice 2. But for this question, we could just go to the y equals and type in the expression. So I'm going to write alpha y equals enter. And we're going to type in this expression here. We have 2x to the power 4, and then we have minus 5x squared plus 3x, and then at the end we have a minus 2. And we're dividing this by, we have x minus 3. So this method, we're going to have to type a lot, but this is a nice backup method. Or if you just want to use the calculator to get to your answer, you could also do this because it is the multiple choice. In the free response, you'd have to show all of your work. But in the multiple choice, you just have to get to the right answer. So here, if I use this method, I just type in the answer choices. And let's say that I already typed in 1 and it didn't match, but I type in choice 2. And now for the last part, I'm going to press plus alpha y equals enter to pull up that fraction. And we have 124 over x minus 3. So now I'm going to press graph here. And the graph from before, the window is all out of whack. So I'm going to press zoom 6 to put it back to standard. And you can see the first one is what we typed in here. And then choice 2, the graphs completely overlap. If I press second graph and go to the table, you could see that our values match here everywhere. And I don't like these fractions. So if that happens, you could just go to mode and go down to answers and switch from auto to decimal. And that's going to switch everything back to decimal value. So I press second graph and you could see that all of our values match. So choice 2 is definitely correct. Question 9, we're looking for the equation of the parabola that has its focus at the point -3, 2 and directrix at y equals 0. So for this question, we can make use of the vertex form of a quadratic equation. And the key detail here, though, is that the a value we could find by looking for 1 over 4p. And I'll get into what this value means in a moment. But what I like to do for these kind of questions is draw them out and really think about what the concept is of a parabola. So when I have a parabola, I have something like this. A parabola is the set of all points that are equidistant from some point that we call the focus and some line that we call the directrix. So you could see here that if I take a random point on my parabola, the distance from this parabola to the directrix is going to be equal to the distance from this point on the parabola to the focus. So that's the concept of what a parabola is. And if I have a parabola where the directrix is here and the focus is underneath, then the parabola will open downwards like this. So that's just something I keep in mind as I'm approaching these questions. So I'll plot this point here. This is our focus. We're going to -3, 2. And this is over here. So I'm just going to call that our focus. And the directrix is at y equals 0. So that's just the x-axis. Okay, so this is where our directrix is. But the concept, once again, is that any point on the parabola is the same distance away from the directrix as it is from the focus. So here, I would pick a point, let's say right in the middle over here. So I go from the focus, I go straight down to the directrix over here. So this is our directrix. And if this is the point over here, -3, 2, that's our focus, then the vertex is going to be at the point -3, 1. Okay, so this would be our vertex. This is the turning point. So this is what I'm looking at here. You could see that the focus lines up with the vertex just like this. So if this is our focus and directrix, the focus lines up with the vertex of the parabola. So I could see right away that our vertex is going to be at the location at -3, 1. Okay, so this is a significant value here. So what that tells us, the vertex is hk. This allows us to start setting up our equation here. So we could say y equals, I'm going to leave a out for now, but we have x minus h, and h over here is -3. So I could write -3, or I could just say x plus 3 squared. And then we have k is plus 1. So I'm looking for an answer choice that's in the form of x plus 3 squared plus 1. And I could eliminate these two answer choices because we have x minus 3 squared and we have x minus 3 squared. But now, like I said before, the a value is 1 over 4p. And p is the distance between the vertex and the focus. So I could see here that this distance here to get from 1 to 2, this tells us the value p is equal to 1. So if I plug in p equals 1, that's going to tell me my a value is 1 over 4 times 1, which is equal to 1/4. Now, one thing I want to point out here is this is a parabola that's opening upwards like this. So this is a situation where the a value, the coefficient of x, is greater than 0. So that's how I know we're not going to get a minus anywhere. If this parabola had opened downwards, all I would do is make this a -1/4, and then I would have x plus 3 squared plus 1. Okay, so that's just something to be mindful of here. But using the formula for the vertex form of a quadratic equation, we're going to see here that our equation of our parabola is going to match up with choice 1. Now, before we move on to the next question, I just want to show a backup method for how to do that last question. This is if you forget the formula, and this method is very exhausting, but it is very reliable if you take the time to learn the algebra, okay? But I would personally just want to know that formula. That'll get you through the question very quickly, but this is backup. Remember what I said before, that the concept of a parabola is that any point on the parabola xy is the same distance away from the directrix as it is from the focus. So what I want to do is I want to find an expression for the distance from here to here and from here to here. So the distance from the x-axis to this point would just be equal to the y value. So I could say y equals, and then if I want to find the distance from here to here, I go back to geometry mode where we had this formula for distance, and we had the square root of x2 minus x1 squared, and then plus y2 minus y1 squared. But one thing that'll make life a little bit easier is if I square both sides, because if I square both sides, that'll get rid of the square root, and that'll be easier to work with the algebra. So instead of setting the distance of these two equal to each other, I'm going to set the square of the distances equal to each other. So now the distance from this point to the focus, I would have x2 minus x1. So I'm doing the x here minus -3 makes x plus 3, and it's squared. And then I have plus y2 minus y1. So I have my y value here minus this y value is 2, and this is being squared. And now I just have to expand this. So this would expand to x squared plus 6x plus 9. But if my goal is ultimately to get this in vertex form, I want to get this in the form of y equals a times x minus h squared and then plus k like this, I could just leave it in this form. I'm going to leave this one unexpanded. So I'm going to leave this one as x plus 3 squared. But this one, y minus 2 squared, that's the same thing as y minus 2 times y minus 2. And I'll just make this a little bit neater. So we have y minus 2 times y minus 2. And this one I would have to expand using the FOIL method or just use the distributive property. So I'd have y squared minus 2y. I would have minus 2y and then plus 4. Okay, so I'm just going to expand this one over here and watch what happens here. So we have y squared and then we have minus 4y plus 4. And notice on both sides we have a y squared. So I could just subtract y squared on both sides. And what we're going to have is these terms cancel, these terms cancel. And then from here, there's a few ways we could proceed, but I'm going to also add 4y to both sides. So I'm going to do plus 4y all in one step like this. And now on the left side, we have 4y equals, and we have x plus 3 squared, and then we have plus 4. And then from here, notice that we're almost in this vertex form. The last step here would be to divide both sides by 4. So I would divide every term here by 4. And what do we have? We have y equals, and then dividing by 4 is the same thing as multiplying by a fourth, x plus 3 squared, and then 4 divided by 4 is 1. And you could see that this matches up with choice 1 from before. Question 10, we want to find the 7th term of the geometric sequence given here. Now, if you go to the reference page, you could find the formula for a geometric sequence, and that's a sub n equals a1 times r to the n minus 1. So this is one of the formulas they give you on the back of the test. So a1 is just equal to the first term, and the first term here is square root 6. To solve for r, the common ratio, you could just take any two consecutive terms and divide them. So maybe here I take these two terms. So I divide, let's say I have 2 radical 6. I'm going to divide that by the term before it, and I have negative 2 radical 3. And then notice here, 2 over 2 cancels. And then radical 6 divided by radical 3 is radical 2. And I have a positive divided by a negative is negative. So I get negative square root 2. Just remember this rule from Algebra 1. The square root of a over the square root of b is the same thing as the square root of, and then I have a over b. Okay, so this is just a very helpful rule that we could use here. I could have divided the second term by the first, but the reason I chose not to is that I knew that when we do this, this would simplify to negative 2 over radical 2. And this is just not as pleasant to work with. We would have to rationalize this denominator. And this would give us negative 2 square root 2 over 2. We still get the same thing, but that's just way messier. So I strategically pick two values to divide that I know the math is going to work out nice. So now that we did this, we have the r value and we have the a sub 1, the first term. We could build our formula. So we have a sub n is equal to, we have the square root of 6, and then r is negative square root 2. And we're raising this to the n minus 1 power. You could, of course, just find r and then get to the 7th term by brute force. But if you want a nice formula here that you could just plug into, you could just build the formula using the formula in the back of the test. So now we're going to find the 7th term. So that's when n is equal to 7. So we have a sub 7, because just be mindful here. I'll just review something, that our first term here is a sub 1. This would be a sub 2. And then we would have a sub 3 and so on like this. So now I could just plug in n equals 7. And we have radical 6 times we have negative square root 2 to the 7 minus 1. If I plug in, 7 minus 1 is equal to 6. So I could just say this is negative root 2 to the 6th power. Now, one thing that jumps out is this power is even. So we have a negative base to an even power. So this is going to work out to something positive. So I could eliminate these two negative answer choices. So from here, what I could do is I could say this is equal to square root 6 times positive square root 2 to the 6th power, because once again, we are raising a negative to an even power. So this is going to work out to something positive. And now from here, I'm going to rewrite square root 2 as 2 to the 1/2 power, and this is being raised to the 6th. Okay, this is just going to make it easier to simplify. At this step, we could just use a calculator and match up with the answer choices here, but I'll do this the algebraic way. So now we have a power to a power, and anytime you have something like a to the b to the c, this is a to the b times c. Okay, so a to the bc. So this would be square root 6 times 2 to the 1/2 times 6 is to the power 3 then, and then 2 to the 3rd is 8. So this will work out to 8 square root of 6, and this matches up with choice 3. But realistically, once you find the r value, you could just find the 7th term by brute force. So we have the 1, 2, 3, 4th term here is negative 4, and then square root 3 like this. And what we could do is we could multiply by the r value is negative, and then we have square root 2. That's second x squared, and then we put a 2 here, and that would give us the 5th term. So now I could just keep doing this. I could do times negative square root 2, and that would give us the 6th term here, and then one more times negative, and then square root 2 would bring us to the 7th term. And then as I run through the answer choices, I try out all of the answer choices, and then by the time I get to 8 square root 6, you could see that this is going to give us the same exact thing here. Question 11, a company wishes to determine the cooking time for 1 pound of spaghetti. The company's technicians cooked 1 pound of spaghetti and recorded the time needed for the spaghetti to be ready to eat. Repeating this process 35 times resulted in an approximately normal distribution. Okay, so that's the $1 million phrase right here. And we have a mean of 9.82 minutes and a standard deviation of 1.4 minutes. In which interval should the middle 95% of cooking times fall? Now, anytime you hear middle 95%, that is plus or minus 2 standard deviations from the mean. So here, what I'm looking at, the mean is 9.82, and I'm going to do plus or minus 2 standard deviations, and the standard deviation is 1.4. So this is something I could just type into the calculator. So we have 9.82, and we're going to do plus 2 standard deviations, so plus 2 times 1.4. So here's the upper end of our interval, and then I just go up to what I typed here. I go up to the plus sign, and I switch it to minus, and that'll give us the lower end of our interval. So our interval here on the lower end is 7.02, and on the upper end is 12.62. So scanning the answer choices, we could see that this matches up with choice 2. Now, this is a big idea for normal distribution. Just know when you have normal distribution, you have this bell curve here, that 1 standard deviation means we're going, this is our mean here, we're exactly at the average. We are 0 standard deviations away from the average. But if I go out 1 standard deviation in both directions, that would highlight about this much of the data. But if I go out 2 standard deviations, it takes up most of the curve and it highlights the middle 95%. Okay, so the middle 95%, you should be thinking plus or minus 2 standard deviations. So we are essentially starting at an average of 9.82, and then each standard deviation puts us forward 1.4. So we're going forward 1.4 twice, and that would bring us here to 12.62. And then if we go backwards 2 standard deviations, that puts us here at 7.02. So this is just a visual representation that highlights what's going on in this question. But for this question here, we're going to get choice 2 is our answer. Question 12, we have these two functions here, and we want to know what is f of x over g of x for all defined values. So for this one, we could just take 2x squared plus 7x minus 15, that's f of x, and we're going to divide it by g of x is 3 minus 2x. Okay, so we're dividing by g of x. But over here, let's do polynomial division. We have to be careful how we write this. So what we're going to do is we're going to write our leading term in the front. The leading term is the highest power of x. that shows up with its coefficient. So we have to write negative 2x and then plus 3, because when we divide, we have to match up the leading terms. A very dangerous mistake you could make here would be to start with 3 and to try doing 2x squared divided by 3. So you just have to make sure that you write your leading term in front when you do this division. So now we're going to do 2x squared divided by negative 2x, and that's going to give us minus x. And here I could see that minus x has to be the leading term here, so these two answer choices are out. And now what we have is negative x times negative 2x is 2x squared, and we have negative x times positive 3 is minus 3x. And now from before, same idea, when we subtract, we just change the sign of everything. Okay, so I'm going to have a minus 2x squared and then plus 3x, and then I combine here. These terms cancel, and then I have 10x, and I bring down the minus 15. And now negative 2x goes into 10x minus 5 times. And if I do minus 5 times minus 2x, I get plus 10x. And then minus 5 times 3 is minus 15. And when I subtract here, I change the sign of everything. I get minus and then plus. These terms cancel completely, and we have no remainder. So we're going to get negative x minus 5. Now, one thing we could do here before we move on is check our answer. So I think about something like 40 divided by 8 is equal to 5. The equivalent multiplication fact would be that 8 times 5 is equal to 40. So if 40 divided by 8 is 5, then 8 times 5 is equal to 40. So I want to use that idea for this question. If this quotient works out to negative x minus 5, then that means when we multiply these two terms here, it should give us the original thing that we started with. So I'm just going to check that over here. If we do minus x minus 5 and we multiply by 3 minus 2x, I'll just go ahead and use the distributive property. So I'm going to do negative x times negative 2x first, and that's going to give us a positive 2x squared. And then I'm going to do negative x times 3 is minus 3x. And then we do negative 5, I'm going to do times negative 2x is positive 10x. And then I'll do negative 5 times 3 is minus 15. So when I combine my like terms here, I'm going to have 2x squared, and then negative 3x plus 10x is plus 7x, and then I get my minus 15. And you could see the match here. So that's how I know choice 1 is definitely correct. Question 13, which equation is equivalent to this one? So it really helps to know a to the b over c is equal to the c root of a to the b power. So anytime I have an exponent term where I have a fraction or a rational exponent, I just think power over root. Okay, so the number on top is the power, and the number on bottom in the denominator represents the root. And that's how we convert to radical form. So here, if we want to rewrite this, we could say p equals, we have 210, and then we're going to have the cube root of x to the fourth. And we'll just make that a little bit neater. So we have x to the fourth power, and we're multiplying by the cube root of y to the 7. Okay, so I'm just using this power over root concept. And now what I could do here is I could use this property of radicals. Anytime I have something like the c root of a times the c root of b, I can combine this into a single radical where I have the c root of a times b. So what I want to do here is I want to break up these radicals, and I'm going to do it one by one. So I have 210, and the cube root of x to the 4, I'm going to write as the cube root of x times the cube root of x to the third power. Okay, so I'm just breaking this radical up into two radicals. And the reason why this is fine is if I multiply x to the first by x to the third, it's going to bring me right back to x to the fourth. Okay, and I'll just write this 3 a little bit over more. I'm just going to put this here so it's not confused with being x to the third here. Okay, so that's what we have. And now we could rewrite the cube root of y to the 7. And for this one, I'm going to rewrite it as the cube root of y, and then I'm going to multiply by the cube root of y to the 6. Now, the reason why I bring this up is I broke these up in such a way that the powers on the inside are divisible by the root in front. So now if I want to use power over root again, I can. Or if you could just do this math in your head, you'll say 210 times the cube root of x, and the cube root of x to the third is x, and then we have the cube root of y, and then the cube root of y to the 6 is y to the second. Okay, so then this simplifies to 210. I have an xy squared, and then I have the cube root of x times the cube root of y is cube root of xy. All right, so if I just do this way, I scan the answer choices and I see that this is going to match up with choice 3. Now, if this step from here to here didn't make a whole lot of sense, basically what I did was I rewrote 210, I rewrote cube root x, but you could think of this term here as x to the power over root. So x to the 3 over 3 simplifies to x to the first. And then I just rewrote cube root of y, but then the cube root of y to the 6 is y to the power over root, y to the 6 over 3, which simplifies to y squared. Okay, and then the stuff that exited the radical, we have an x and a y squared, went over here. And then these two terms over here, the cube root of x and cube root of y, we just squeeze back together using this property of radicals. So we get choice 3. Question 14, we have the average cost of a gallon of milk in the United States between the years of 1995 and 2018 can be modeled by this equation here. And P of t represents the cost in dollars, and t is the time in years since January 1995. And we want to know during this time period, in what year did P of t reach its maximum? So let's go over to the y equals and we'll type in the function P of t. So now that we have everything typed in, let's think about t is the time in years since January 1995. And the last answer choice here, choice 4, has the latest year at 2018, which is 23 years after 1995. So when I make my graph here, I'm going to go over to the x minimum. I'm going to start at 0, and I'm going to go out to 25, because 23 years goes by to bring us from 1995 to 2018. So I need to go out far enough to capture the maximum and something that'll cover one of these answer choices here. So now we press graph, and notice we have this picture here. We could see the maximum is somewhere over here in this neighborhood. So I'm going to press second trace, maximum is number 4, and I scroll to this neighborhood here. Notice my y values are going up, and I press enter once before the hill, and then I go after the hill when my values start to drop, and I press enter a second time and a third time, and here's our maximum. So the maximum will occur when x equals 18.3 if I round to the nearest tenth. But remember, t represents the number of years since 1995. So I'm going to take 1995 and I'm going to add 18.3. Okay, so we just add this up here. And if we work this out, we have 3 after the decimal. And then we have 13, we carry the 1. We have 11, we carry the 1. We have 10, we carry the 1. So we have 2013.3. But remember, we want to know in what year did P of t reach its maximum. So if this is 18.3 years after January 1995, that means we will be in the year 2013 when this function reaches its maximum. Okay, so choice 2 would be our answer. We're not going to go with choice 3. This is not one of those situations where we would want to round, even if we had something like 0.5, because if we have a decimal after the year, this means that we're in the middle of that year. So they're asking during this time period, in what year did this occur? So this occurs in 2013. Question 15, the temperature F in degrees Fahrenheit after t hours of a roast put into an oven is given by this equation here. And we want to know what was the temperature of the roast when it was put into the oven. So for this question here, this represents time t equals 0, because they're saying what was the temperature of the roast when it was put into the oven. And they're telling us t represents the number of hours after a roast was put into the oven. Okay, so after t hours of a roast put into the oven tells us here at the end they're asking about t equals 0. So all we have to do here is plug in t equals 0 to the equation, and we're going to have F equals, we have 325 minus 185, and then I have e to the negative 0.4 times 0. So this is something I could just type right into the calculator. Or one thing I could just note here is that e to the 0 is equal to 1. So when I have my exponent here multiplied by 0 at the end, this is just going to work out to e to the 0, which is 1. So I'm going to have 325 minus 185 times e to the 0. And once again, e to the 0 is equal to 1. So we're really just doing 325 minus 185. And this we just work out. So I'm going to borrow here, and I have 12 minus 8 is 4. 2 minus 1 is 1. So 140 degrees Fahrenheit was the temperature of the roast when it was first put into the oven. Question 16, the roots of the equation here in simplest a plus bi form are, and we have these four answer choices here. So we have a quadratic equation, and it's in the form ax squared plus bx plus c is equal to 0. So we could use the quadratic formula here. The quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here I just identify our a value is equal to 1. That's the number in front of x squared. And if there's no number written there, the invisible number is 1. And then we have b is equal to 6 and c is equal to 10. So I just plug these values now into that formula. So we're going to have x equals negative b, I'm going to write negative 6, plus or minus the square root of, and then we have b squared, so that's going to be 6 squared. And then we have minus 4 times a is equal to 1, and c is equal to 10. And we're dividing all of this by 2a, so I have 2 times 1. Now, the reason I put this first term in parentheses is if b is ever negative, the most common mistake here is that when people do something like, let's say, negative 6 squared, without the parentheses, the calculator is going to tell you negative 36. And the reason behind this is that negative 6 squared is the same thing as negative 1 times 6 squared. So when you're plugging into the quadratic formula, especially this piece in front, just put parentheses for this term here, because once again, the most common mistake is that when people type this into the calculator, they type it in wrong and then it throws the whole question off. So now from here, we could just simplify. We have negative 6, and then we have plus or minus, and on the inside here, we have 6 squared is 36, minus 4 times 1 times 10 is 40, and 36 minus 40 is negative 4. And we're dividing all of this by 2 times 1, which is 2. So then the next big idea that we need is that the square root of negative 1 is equal to I. So anytime I take the square root of something and there's a negative in front, I just bring out the I with it. So if I have something like the square root of negative 4, I know that this is 2i. I'm doing the square root of 4 is 2, and the square root, the negative, comes out as I. So here, now we have negative 6 plus or minus, and we have 2i divided by 2, and now I'm just going to divide each piece by 2. So we have negative 6 over 2 plus or minus 2i over 2. And now finally, we could simplify this. We could say that negative 6 divided by 2 is negative 3. And then we have plus or minus 2 divided by 2 is 1. So the I just carries down like this. These terms just cancel out. And we scan the answer choices. This is going to match up with choice 3. But one more thing we could do here, we could go over to mode and we could switch the numbers from real to a plus bi. And what I could do is I could just type these roots in one by one. So I'm going to press alpha y equals enter. And I'm going to write in this entire numerator. So we have negative 6 plus or minus, but first I'll write plus, and then I have the square root of, and I'm going to put parentheses here, just like I said before, that if I leave the parentheses off for negative numbers, that's going to throw everything off. So I'm just typing in our expression here, and in the denominator, we have 2 times 1. I'll pretend I don't know that 2 times 1 is equal to 2. And now I press enter, and see it gives us negative 3 plus I, which was one of our answers. And now I could just go up to this, and remember, the quadratic formula says plus or minus. So I just scroll to the left until I get to that plus sign, and I press minus to go over it. And notice I get negative 3 minus I, which is both of our answers. So we really don't have to do much work here at all except type into the calculator, but I did want to show how to do this by hand. Question 17, which equation does not represent an identity? So for this one here, if you just know all of the algebra, you could look at something like choice 1 and say, this is a difference of 2 squares when I have x squared minus y squared, and this does factor nicely to x plus y times x minus y. If you really wanted to check why this is an identity and why we can eliminate it, we could take the right-hand side, the x plus y times x minus y, and we could actually multiply things out. So if I did x times x is x squared, and then I have minus xy, and when I distribute the second term here, I'm going to have y times x, or I could say plus xy, and then y times minus y is minus y squared. And notice the middle terms cancel, giving us x squared minus y squared. So this one is an identity. And the same idea for the next one. If I write x minus y squared, I could write it as the product of x minus y times x minus y. So this is just the definition of an exponent. So that's why 2 is definitely an identity because this we're just using the definition of an exponent. So this will work every single time. And now for the next one here, we could just multiply this out. We could do x plus y times x plus y. And for this one, if we work it out, we have x times x is x squared. We have x times y is xy. And then we have y times x is another xy. Remember, multiplication, the order doesn't matter. I could just flip those. And then y times y is y squared. So this simplifies to x squared plus 2xy plus y squared. And finally, for the last one, this has to be our answer because notice that we got a match here for expanding x plus y times x plus y. So whatever choice 4 is has to be the one that does not represent an identity. But how do I know this is the case? Well, if I want to, I could take x plus y squared and multiply it by x plus y. So I could just do times another x plus y here. So I have x plus y squared, and I could just multiply that by x plus y, and that's going to make x plus y to the third. So that would give us, we would have x squared plus 2xy plus y squared, and we'll just make this a little bit neater. So we have plus 2xy plus y squared. So I'm just replacing this piece with the expansion we just did in the previous line, and we multiply by x plus y. So I could do this, but this is going to be very time consuming. But another really cool thing I could do is I could use Pascal's triangle. All right, so here I'm going to use Pascal's triangle. Now, if you've never heard of Pascal's triangle, it starts off with this triangular array of 1, and I keep going down like this, but then to get the next row, I do 1 plus 1 is 2. So I put another 1 along the diagonals like this, but then I do 1 plus 2 is 3, 2 plus 1 is 3, and I can keep going if I want, but this is more than enough. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And what this does is if I want to do something like, let's say x plus y squared, if I want to redo this, okay, so using the triangle, how could I use this triangle strategically? Well, x plus y squared, this is telling us the coefficients of x plus y squared. I know that I'm going to have an x squared term, I'm going to have an xy term, and I'm going to have a y squared term, but this tells us the coefficients. It's going to be 1x squared plus 2xy plus 1y squared. So if I want to do x plus y to the third, I know the terms are going to start here at, let's say, x to the third, and then I could have, after this, the powers descend to x squared, but then we pick up a y term, and then I would have plus, I would have an x term. See, I go from x to the third to x to the second to x to the first, but then my y term bumps up to y squared. And then finally, my x term disappears, and I have y to the third. So then these would be the coefficients here. I would have 1x to the third plus 3x squared y plus 3xy squared plus 1y to the third. If I had to keep going here, I could just do one more. This would give us, if I use the next row, I would have 1x to the fourth, and then my next value would be x to the third y. I just drop the power down like this, and I would have a 4 in front. So this would tell me the coefficient. And then next, I would have 6x squared y squared. So the x goes down a power, and the y goes up a power. And then next, I'd have xy to the third power, which would give me the coefficient 4 here. And then finally, I end with y to the fourth. So this is just a nice, cool way to expand binomials based on their power using this triangle. But in either case here, we're going to get choice 4. Question 18, we have 2 surveys were conducted to estimate the proportion of teens who use social media at least once per day. And here are the results of the 2 surveys. And then we have, based on these results, it was determined that approximately 75% of teens use social media at least once per day. And we want to know what is the best explanation. So the best explanation of the difference in the results between the 2 surveys. So here we have one survey where we have 100 samples of 5 teens. And then here we have 100 samples of 50 teens. Okay, so this one here is a much bigger sample size. Okay, so this one here is a bigger sample size. And the big idea for statistics is that if you have a bigger sample size, your results are just going to be more accurate in your survey. Okay, so the more people you could survey, the better. So that's just an idea that I'm coming into with this question as I look through the answer choices. So for choice 1, we have the smaller sample size resulted in a smaller margin of error, and this provided a more accurate estimate. So just this phrase together, the small sample size provided a more accurate estimate is out, because the bigger the sample size, the more accurate the estimate is going to be. So now we go down to the last two answer choices to see which one is the better answer choice. So we have the large sample size of 50 teens resulted in a smaller margin of error and should provide a more accurate estimate. And then we have the large sample size of 50 teens resulted in a bigger margin of error. So here, if we look at the results, we have the mean value here, and then we have the standard deviation here is 0.207, and the standard deviation here is much smaller. It's 0.057. So this, think of as your margin of error. Okay, so the standard deviation in a way tells you your margin of error. So here, for the bigger sample size, we have a smaller margin of error, which means we have a more accurate estimate. Okay, so choice 3 is going to be our answer. And once again, the big idea is that the bigger the sample size here, the more accurate your survey is going to be. And the standard deviation should shrink if you have a bigger sample size. Okay, it's going to give you a better idea, in this case, of the proportion of teens who use social media at least once per day. Question 19, we have f of x and f inverse of x, and we want to know the value of b. So for this one, I go through the process exactly the same as I would if this were just a normal find the inverse function question. So here, just know y equals f of x. And when you want to find the inverse function, you switch the x's and the y's, and then you solve for y. So here, I just imagine this as y equals, and then I'm going to say x equals y to the third, and then minus 3. So now I'm just solving for y. So from here, what I'm going to do is I'm going to add 3 to both sides of this equation. So we're going to have plus 3 on both sides. And now minus 3 plus 3 cancels. And this gives us x plus 3 is equal to, and then we have y to the third power. And now to get y by itself, remember the goal is to solve for y. I'm going to take the cube root of both sides. That's going to get rid of that power 3. So we have cube root on the left and right side. And this tells us that y is equal to the cube root of x plus 3. But I could name this as our inverse function. I could say f inverse of x is equal to, and then I have the cube root of x plus 3. But notice in this question here, we have the cube root of x minus 3b. And this term here, the minus 3b, is matching up with the plus 3. So now I'm going to set these two terms equal to each other. I'm going to set minus 3b equal to 3. And if I solve for b, I'm going to divide both sides by negative 3. This tells us that b is equal to negative 1. And we could even see here, if we plug in b equals negative 1, we're going to get the cube root of x minus 3 times b is negative 1. And if I do negative 3 times negative 1, that's going to give us positive 3. And notice that I get the exact same inverse function here. So b equals negative 1, choice 2 is our solution. Question 20, Robert is buying a car that costs $22,000. After a down payment of $4,000, he borrows the remainder from a bank, a 6-year loan at 6.24% annual interest rate. The following formula can be used to calculate his monthly loan payment. And here's this crazy formula over here. And we want to know what Robert's monthly payment will be. So for this one, we just have to go piece by piece and find everything in the question. So here, what we have is Robert is buying a car that costs $22,000. And what we have is P is the loan amount. So we have to calculate the loan amount is how much money he owes on the car after his down payment. So he makes a down payment of $4,000. So if the car is $22,000 and he makes a $4,000 down payment, that means he owes $18,000 on the car. Okay, so the loan amount, P, is going to be $18,000. Now, the next thing that we're finding here is the monthly interest rate. So if he's paying 6.24%, and that's the annual means per year. Okay, so this is per year. So he's paying 6.24%, and this is per year. So if we want to convert this to a monthly interest rate, we need to make use of the idea that 1 year is the same thing as 12 months. Okay, so what we have here is we have 1 year is equal to 12 months. So what I could do is I just cross out these units, and now I'm going to do 6.24% divided by 12. But be mindful here, we have to express the percent as a decimal. So 6.24%, I'll just do that on the side, is 6.24 out of 100. And this, if we just type it into a calculator, is going to be 0.0 0.0624, or you could just move the decimal 2 places to the left to get this decimal here. So now we're going to do 0.0624 divided by 12, and this is going to be our monthly interest rate. So we have 0.0624, and we're dividing this by 12, and here is our monthly interest rate. So we can name this as the variable I so that it matches the question. So we have I equals, and this simplifies to 0.0052. And then the next thing we have to find here is T, which is the time in months. So looking at this, we were told that this is a 6-year loan. So 6 years, I'm going to write this over here. We have T equals, we have 6 years, but we want the time in months. So we're going to multiply here. There are 12 months in 1 year. Okay, so 12 months in 1 year, and notice the units cancel out. So years over years cancels. And if we do 6 times 12, that's going to be 72 months. Okay, so we have 72 months. So now we're ready to plug all of these values into the formula. So the rest here is calculator work, but once again, now we just plug in all of these values here. So I'm going to type in alpha y equals enter to pull up a blank fraction, and we have p times I. So we have p is equal to, we have 18,000, and then I we have written down here is we have 0. And then we have 0052. And then in the denominator of this formula, we have 1 minus, so I'm going to have 1 minus, and then I put parentheses. We have 1 plus I, and I once again is 0.0052. So we have 0.0052, and this is being raised to the negative t power. So if t is 72, we're raising this to the negative 72 power, and here's our monthly payment. So we look at this value here, we have 300.355. So if we round to the nearest cent, to the right of the 5 is a 5, so we would round this to $300.36, and this is going to match up with choice 2. Question 21, given tangent theta equals -4/3 and theta is between pi over 2 and pi, what is the value of secant theta? So for this question, it helps to know how to think about trig functions on the xy axis. So here, for one, our interval is between pi over 2 and pi. So they're giving us an interval in radian measure. So just know that if we're over here, we're at 0 radians and 0 degrees. In this position up here, we're at 90 degrees or we're at pi over 2 radians. And then when we're facing this way, we're at 180 degrees, or we could say pi radians. And then over here, this is 270 degrees, but in radians, that would be 3 pi over 2. And then I could go 360 degrees to go back to where I started, and I would be 360 degrees, or I could say 2 pi radians. So it just helps to know the radian measure, because what this is really saying is that theta terminates in quadrant 2. Okay, so angle theta starts in standard position, it spins like this. So there's theta, and it terminates in quadrant 2. So we'll just make this a little bit neater here. So here is our angle theta. And what we're going to make use of for this question is the concept of reference angles. So I drop down my right triangle, and the reference angle is the positive acute angle between the terminal side of the angle. So here's our terminal side. That's where the angle ends. And the x-axis. Okay, so the terminal side and the x-axis. So now we have this ratio tangent theta equals -4/3. And remember the phrase SOHCAHTOA. This helps us remember the ratios for sine, cosine, and tangent. So tangent is the ratio of the side opposite and over the adjacent side. Okay, so we have opposite over adjacent. So when I label this triangle over here, this right triangle, I'm going opposite of the reference angle and I'm writing a 4. And then I'm going adjacent and I'm writing a 3. So I'll just make that a little bit neater. So we have 4 going here and 3 going here. Now the reason why it's negative is because technically if I were plotting this point over here, I would go to the left x and up y. So we could think of this 3 as a -3, and then 4 over -3 is -4/3. Or what you could do is you could just think of ASTC. So when you have ASTC, this helps you remember which trig functions are positive in which quadrants. So in quadrant 1, all of the trig functions are positive and they're reciprocals. In quadrant 2, we have sine theta and its reciprocal cosecant theta are positive. And then in quadrant 3, I would have tangent theta and its reciprocal cotangent are positive. And then in quadrant 4, cosine theta and its reciprocal secant theta are positive. And what I mean by that is when we plug in an angle that terminates in, let's say, quadrant 2 into the sine function, we're going to get a positive ratio. And the same thing would happen if I plug it into its reciprocal cosecant. So now we have this right triangle over here, this 3, 4, the hypotenuse is going to be 5. And the reason I know this is that this is a popular 3, 4, 5 Pythagorean triple. If we wanted to, we could use Pythagorean theorem to solve for that missing side. But this is a nice triangle, so we could just say 3, 4, 5. So the next thing we have to know is that secant theta is the reciprocal of cosine. This is 1 over cosine theta. And remember what we said before, only sine and its reciprocal are positive in quadrant 2. So if I have a quadrant 2 angle being plugged in to the secant function here, I know that I'm getting something negative because secant is not the reciprocal of sine, it's the reciprocal of cosine. So if I had a quadrant 4 angle being plugged in, then I know I would have positive answers. So we could narrow it down to just these two answer choices here. But now what I could do is I could find cosine of theta. So cosine of theta is going to be negative because we're in quadrant 2. And then adjacent, so this is the side adjacent to the reference angle, is 3 over the hypotenuse is 5. But the relationship between secant and cosecant, the relationship between secant theta and cosine theta is that these are reciprocals. Okay, so secant theta is the reciprocal of cosine. So all I'd have to do here to find secant theta, so secant theta, I would just take the reciprocal, or I would flip this, and this would make negative 5 over 3 like this. Okay, so our correct answer here is going to be choice 1. We could also use technology here to help us, and just know that we would have to switch back and forth between radians and degrees to use this trick. So when I have to graph a trig function later on in the test, I have to be in radian mode. But when I want to just check things, I could be in degree mode like this. So I'm going to go over to degree mode, and I'm going to do tangent inverse of just 4 over 3. And what this is going to tell us is that our reference angle is 53.13 degrees. So if I want to find the quadrant 2 angle, I just do 180 minus this reference angle. So 180 minus this. And this tells us the actual angle here is this value here. And I'm going to press store. I'm going to store this as the letter A. So I'm going to press alpha math. And now anytime I write the letter A, that's just going to give us the angle that we found. So watch what happens if I do tangent of that angle. So tangent of that angle, I press math, enter, enter. It should give me negative 4/3. I don't know why that didn't work just now, but whatever. Negative 4/3 is going to give us the same thing. So if I want to find secant theta, we said before that's 1 over cosine. So I could do 1 divided by cosine of that angle A. And when I press enter, notice that we get negative 5/3. Okay, math, enter, enter may or may not work here, and it's just deciding not to work. But negative 5/3 is going to give us the same decimal. What I mean by that is if I just were to write something like this, like 0.2 repeating, so I just write in a bunch of 2's like this and press enter. When I press math, enter, enter, this is just a nice way to turn a decimal back into a fraction. But sometimes when you're dealing with trig functions, the calculator won't do it. So then you could just type in the answers to see if the decimal values match. But otherwise here, using the calculator, we could see that choice 1 is our answer. Question 22, to solve this equation here, Jones' first step is to multiply both sides by the least common denominator. And we want to know which statement is true. And for this question here, there's a lot of statements here involving extraneous solutions. So the first thing I like to do when I solve a rational equation like this is I like to identify the x values that are just not possible. So in my head, I set the factors in the denominator equal to 0. And this will tell us that x is not allowed to equal plus or minus 7. Okay, so I can't have x equal to negative 7 or positive 7. This is just not going to be possible because if I had negative 7, I would have negative 7 plus 7 is 0, and division by 0 is not allowed. And if I had x equals positive 7, 7 minus 7 would give us a 0 denominator. And once again, that's just not okay. So now we follow Jones' step here. So she's starting with this equation over here. We have 7 over x plus 7, and then we have plus 4x over x minus 7. And this is equal to, I'll leave a space, we have 3x plus 7 over x minus 7. So the first thing that Joan is doing is multiplying both sides by the least common denominator. So the least common denominator here is going to be x plus 7 times x minus 7. And the way I find the least common denominator is I just look at all of the unique factors in the rational equation. And I just write all of the unique factors down. So here we have an x plus 7, and we have an x minus 7 that shows up twice, but I only need to write it once. So then what Joan is doing is, once again, multiplying both sides by the least common denominator. So if we multiply everything here by x plus 7, x minus 7, so here is our least common denominator. We're multiplying both sides by the least common denominator. So I'm just going to write it here and here, because if I multiply the left side by the least common denominator, I have to distribute it across and multiply each of these terms by it. We'll have x plus 7 times x minus 7. Okay, so here is our least common denominator showing up 3 times. Okay, we're multiplying both sides by the least common denominator. And watch what happens. X plus 7 over x plus 7 cancels. Then we have x minus 7 over x minus 7 canceling. And then we have x minus 7 over x minus 7 canceling. And the leftovers here, we have 7 times x minus 7. So I have 7 times x minus 7. And then plus we have 4x times x plus 7. And this is equal to, we have 3x plus 7 times x plus 7. And then our goal here is going to be to find the solution to this equation here, or the multiple solution. So we could do all of this algebra, or we could just type the left side of the equation into the y1 spot and the right side of the equation into the y2 spot. So now we press graph here just to get an idea of what both of these graphs look like. And I'm going to press zoom 6 to put the graph back to normal. And it's a little bit difficult here to see what's going on. But notice that we have potential solutions are -14, -7, and 7. So I'm going to press second graph here to go to the table and look at -14. What we have is we have a match. So this tells me that -14 is a solution to this equation down here. But this is not an extraneous solution because we excluded the values early on. We said x cannot equal -7 or +7. Those are out. So those are the ones I want to check for. But notice here, when x equals -7, the y values are different. So x equals -7 is not showing up as a solution here. If I look at x equals +7, notice that I do get a match. So I know that x equals 7 is going to show up as a solution, but I have to exclude it because we said in the beginning x equals 7 is not allowed. Now, if I want to see this on the graph, notice this goes all the way up to almost 400. So if I press window and I put the y maximum up to 400, then I'll be able to see the intersection of these two graphs here. So the intersection is happening somewhere over here. So I'll just gather all of these values all at once. I'm going to press second window and go to the independent variable and switch it from auto to ask. That way I could just type in custom values here. So we have -14, and that gave us matching y values. So x equals -14 is a solution. And then we have -7 and we have +7. But remember, 7 shows up as a solution, but we have to reject it. This was one of the values of x that was not allowed. So we'll just summarize what we have here. This represents a solution because the y values match when we graph the left side here in this equation over here. We have the left side was our y1 and the right side was our y2. So x equals -14 is a solution. This one is not a solution because the y values don't match. And this one we have to reject because of what we said in the beginning, that x equals 7 here would give an undefined value. So this one gets rejected. So what we have is that 7 is an extraneous solution. Now, one extra thing before we move on, I'm just going to expand this and solve this algebraically. So here I would have 7 times x is 7x, 7 times -7 is -49, and then I would have 4x times x is 4x squared, and then 4x times 7 would give us 28x. And now this is equal to, I expand these two, so I'm doing 3x times x is 3x squared, 3x times 7 is 21x, and then I distribute the 7. I have 7 times x is 7x, and then 7 times 7 is 49. And then from here, I want to get everything to one side. So I'm going to do -3x squared on both sides. So I have -3x squared. And what I have on the right side is these terms cancel out. Now 21x plus 7x is equal to 28x. So I'm just going to write -28x on both sides. And subtracting 28x on both sides, you see is going to cancel these two terms out. And then I'll do -49 like this on both sides. So I have -49. And now everything on the right side just canceled. We have 0. And now 4x squared minus 3x squared, I'll write first, is 1x squared. And then we have 28x minus 28x canceling out. We have a plus 7x. And then -49 minus 49 is going to give us minus 98. Now from before, I used the idea that we said x equals negative 14 was a solution. So that's going to help us come up with the factors here. We need two numbers that have a sum of 7 and a product of negative 98. And the two numbers, if you think about it, would be x plus 14 and x minus 7. 14 minus 7 is 7, and when you multiply those two, you get negative 98. And then the roots here would be x equals negative 14 and positive 7. But once again, we said before x equals 7 was forbidden. We'd have to reject this. So x equals negative 14 would be the only solution here. This one here would be extraneous. We would have to reject this. So our answer from before is definitely correct. Question 23, beginning July 1st, 2019, Michelle deposited $250 into an account that yields 0.15% each month. And she continued to make these $250 deposits into this account on the first of each month for 3 years. Okay, so she's making these deposits every month for 3 years, and we want to know which expression represents the amount of money that was in the account after her last deposit was made on June 1st, 2022. So here what we want to do is think about what's going on here. We're looking at Michelle's account, and she starts off here just by depositing $250 in the account. And this account is earning 0.15% each month. So 0.15% is the same thing as 0.15 over 100. And this would expand to we'd have 0015. I could just move this decimal 2 places to the left. And now another idea we want to make use of here, this reminds me of the formula A equals, and we have P times 1 plus or minus R to the power T. So I could just use compound interest here, this concept, even though the interest is compounding monthly. But the idea is that we want to do 1 plus R to come up with the percent growth here. So here, if I add this value to 1, because the account is growing by this amount here, I would have 1.0015. Okay, so that's where in the next line here, I look at the situation that Michelle deposits another $250, but the previous $250 just grew by 0.15%. So we could find the new value here by multiplying it by 1.0015. Okay, so the idea of doing 1 plus the interest rate, that's where this is coming from. So now let's look at the third month. In the third month, Michelle deposits another $250, but this previous $250 matures by a factor of 1.0015. But the value to pay attention to is this one. What about the one that already matured by 0.15%? It's going to mature a second time. So if we multiply by that factor again, that's going to bump the power up to 0015 to the second power. So what we should note here is that we have a geometric series. Notice that we are adding terms of a geometric sequence here, that the terms here are increasing each time by a factor of r. So our common ratio here is 1.0015. So that's the idea we want to make use of here. And this formula is actually on the Regents on the reference page here. So we want to know how much money is in this account after 3 years. Well, 3 years, if we multiply 3 by 12, tells us that 3 years is equal to 36 months. Because remember, this is going on a monthly basis. So if 36 months goes by, this is looking at S sub 36. So S sub 36 just means if we were to just keep adding the 36 terms here representing each of the amounts that Michelle is depositing each month, and they're growing 0.15% each month. This would be the pattern going on to S sub 36. So here we have A sub 1. This is the first term. Okay, so this is the first term of any of these partial sums here. And the first term here is 250. And then we're going to have 250 minus A1 is still 250. But the R value, that's the common ratio. That's what we're multiplying by each time. So our R value we could find from any one of these is 1.0015. Okay, so there's our R value. And we're going to have 1.0015 to the n power. And n is going to match the subscript of our partial sum. So this is going to go up to the 36th power. And then we divide by 1 minus r is 1.0015. And we don't actually have to find the sum here. We just have to see which answer choices going to match us up. So we look here and we could see that this is going to match up with choice 4. The problem with choice 3 is that the power is all off, that they left the power in terms of years. But remember, Michelle is depositing this money each month, so we have to count it by months. So 36 months goes by when 3 years goes by. Choice 4 is definitely our answer. Question 24, our last multiple choice question. We have a study of the red-tailed hawk population in a given area shows the population h of t can be represented by the function here, where t represents the number of years since the study began. In terms of the monthly rate of growth, the population can be best approximated by the function, and we have these 4 options here. Now, the big technique we need for this question is a to the b to the c power equals a to the b times c. We need this property of exponents. And what I'm thinking of here is that t is represented as the number of years. Okay, so t is the number of years. So if I want to write the function in terms of the monthly rate of growth, well, if t represents years, if I multiply t by 12, 12 times t would be the number of months. And just think about this. If 3 years went by, let's say I had t equals 3 years, 12 times 3 would be 36, and 36 months would go by. So this is the idea we want to make use of. So now that we have the function h of t, we are going to use this idea to try to build up the function in terms of 12t. So now let's go ahead and do that. We have h of t is equal to, we have 50 times 1.19 to the t power. But what I want to do here is I want to rearrange t in such a way that it's in terms of 12t. So we have 50 times 1.19. And what I'm going to do is I'm going to express t as 12 times t times 1 over 12. Okay, I could also say 1 over 12 times 12t because multiplication is commutative. So this one here is actually the better one for us to use. So I'm going to call this 1 over 12 and then times 12t. But remember, when I have a product, I could write this as a power to a power. So now I could say this is equal to, I have 50, and then I'm multiplying by 1.19 to the 1 over 12, but then I'm raising this to the 12t power. And notice that if I were to multiply these two powers together, it would bring us right back to where we started. So these are definitely equivalent. But now what we're going to do is we're going to ask the calculator, what is 1.19 to the 1/12th power? Now, I know taking the 12th root of this number is only going to make it smaller. So just using that common sense idea, I could see that our new base is going to be something smaller. So choice 1 would have to be our answer. But let's use the calculator to verify. So we'll just type in this base here. We have 1.19, and we're raising this to the 1/12th power. So 1 divided by 12. And this is the decimal value we get. So we'll simplify the highlighted part here, and we'll round to 3 decimal places. So we have 50, and then we have times 1 point, and we're going out here to 3 decimal places. So to the right of the 4 is a 6, so we're going to round this up to 1.015. That's the highlighted stuff to the 12t power, and we can see that this does match up with choice 1.